So again, we're looking at algebraic fractions. This time we're looking at equations involving algebraic fractions. So we're actually going to be solving these, so as in we can find the missing value within them. Our previous videos, we looked at how we manipulate algebraic expressions, adding two algebraic fractions together to form a single simplified algebraic fraction. Well, we can use those rules to help us when it comes to solving equations involving algebraic fractions. We're going to start off with the most basic types of equations and progressively work our way up over the next few videos to the hardest types of equation. So some of these you will have already encountered, some of these types of equations. Some of them are very basic two-step equations, but again they involve algebraic fractions, so we're going to include them in this lesson. Okay, so the first one, and again our most basic type of equation, and again you'll notice because we're dealing with equations when asked to solve, a over 2 equals 6. So whenever we're trying to solve an equation in algebra, and again if you watch any of the videos to do with solving equations, what we're trying to do is get the letter that we're trying to find on its own. So we're trying to get rid of the 2 over here. Treat the equals like the middle of the equation. Both sides are balanced like a seesaw or a set of scales. What we need to do is we need to do the opposite whenever we're getting rid of terms. So if I want to get rid of this 2 is dividing, and this will be quite common when dealing with algebraic fractions. This 2 is dividing, so do the opposite of divide by 2, which is multiply by 2. And because we're treating it like a set of scales, whatever we do to the left hand side, we do to the right hand side. So if I multiply by 2 on the left, I have to multiply by 2 on the right. So that gets rid of the 2 on the bottom, so I'm just left with a, and 6 times 2 is 12. And again, with any of these, if you want to check them, you can always substitute your answer back into the equation, even with the most simple ones. So if a is 12, 12 divided by 2 does in fact equal 6. So moving on from this, I mean, this is a two-step equation. We have covered this before, but because it involves an algebraic fraction, we're going to look at it again. B over 4 plus 1 equals 9. So we're working backwards to get b on its own, so we need to get rid of the 4 and the 1. Because this 1 is on its own, we're going to get rid of the plus 1 first. To get rid of the plus 1, we subtract 1. If I subtract 1 from the left, I subtract 1 from the right. So I'm left with b over 4. It's a two-step equation, so I'm taking 2 steps to solve it. I'm going to get rid of that 4 in a wee second. Plus 1 minus 1 is 0, so it's gone. That was the purpose of taking away the 1. 9 take away 1 is now 8. Okay, and now I want to get rid of this 4 on the bottom. So remember, this 4 is dividing, so to get rid of divide by 4, I multiply by 4. But remember, I have to multiply by 4 on the right as well. So that leaves me with b on the left. 8 times 4 is 32. And I mean, we can substitute that back in just to check our answer. 32 divided by 4 is 8, plus 1 is in fact 9. Okay? Moving on, another type of two-step equation which we have again looked at, but again just comparing example 2 and example 3, you'll see the slight difference here. So c plus 1 all over 2, that's a big difference between this where it was just b over the 4. So c plus 1 all over 2 equals 3. So when this happens, we're getting rid of the 2 on the bottom line first. Okay, so to get rid of divide by 2, I multiply by 2. If I multiply by 2 on the left, I multiply by 2 on the right. So I'm left with c plus 1, because I've got rid of that 2 on the bottom, is equal to 3 times 2, which is 6. And now I get rid of that plus 1, so I subtract 1. If I subtract 1 from the left, I subtract 1 from the right. So I'm left with c is equal to 6 take away 1, which is 5. And again, we can substitute our answer, c equals 5, back into the question. So 5 plus 1 is 6. 6 divided by 2 is in fact 3. So that makes perfect sense. Okay. Moving on, our fourth example, so 2d over 3 equals 6. So again, because this is all over 3, similarly to the previous example, we're going to get rid of the 3 on the bottom line first. So to get rid of that 3, I multiply by 3 because it is dividing. So I multiply by 3, I multiply by 3 on the right as well. So that gets rid of the 3 on the bottom. So I'm left with 2d is equal to 6 times 3, which is 18. And now I get rid of this 2. Now remember, this 2 is multiplying with the d. It's 2 times d. So I divide by 2 to get rid of the 2. And I have to do the same to the right hand side. So 2d divided by 2 is 1d, which is just d. 18 divided by 2, which is just 9. And I mean, again, that makes sense. So if d was 9, 2 times 9 is 18. 18 divided by 3 is 6. So again, just substituting my answer back in to check it. We'll finish off with this type of example today. and then we'll move on to trickier ones after this as well. So again, we have a 3, a 5 and a 2 to get rid of. Because we're dividing the whole thing by 2 on the left here, we're going to get rid of the 2 first. So 3 steps to solve this one. So multiply by 2 on the left, I have to multiply by 2 on the right because this 2 is dividing. So I'm left with 3e plus 5 because I've got rid of the 2 on the bottom now. 7 times 2 is 14. Now again, this is now a two-step equation. So 3e plus 5, I get rid of the 5 next, working backwards. So obviously plus 5 is minus 5, but I have the minus 5 on the right as well. So I'm left with 3e plus 5 minus 5 is 0, so it's gone. 14 take away 5 is 9. And then to get rid of this 3, because it's multiplying, I divide by 3. If I divide by 3 on the left, I have to divide by 3 on the right also. So I'm left with 3e divided by 3 is 1e, or e. 9 divided by 3, which is 3. And again, let's substitute e being 3 back into this. 3 times 3 is 9. 9 plus 5 is 14. 14 divided by 2 is in fact 7. So I'll post a couple of questions for you to try. Anything you're unsure about, just ask, and we'll move on to our harder types of questions in the next lesson.